Hey there, folks. Okay, going to take you through some quick notes on page 6 that'll give you an overview of what the heck Unit 8 is about. So this chart should maybe be vaguely familiar looking from the shape of it. If we start up here with all matter, then we're going to divide it into two categories. And I'm thinking maybe you can make some predictions here, but I'm just going to run right through it. We got pure substances and we've got mixtures. Now, in this unit, we're not going to worry so much about mixtures. That we talked a lot about mixtures when we were talking about solutions, but in this unit, we're going to focus on the pure substances. Those would be the elements, metals, nonmetals, and metalloids, and the compounds. Remember, elements and compounds are both types of pure substances. And compounds could be ionic or they could be covalent. And what I want to stress now is the term molecular is a synonym for covalent. Okay. And then the last thing to point out is organic chemistry, which you may have heard of organic chemistry, the chemistry of compounds that have a lot of carbon atoms in them. That falls under our covalent compounds or molecular compounds. So the stuff right here that's in blue is going to be new stuff that we're really going to focus on in this unit. Metals, ionic and molecular or covalent compounds, we're going to go deeper into those, and we're going to learn about organic chemistry. So there you go, little overview. Okay, on page 8, this is going to be mostly recap of the types of bonding. Two of them you've learned about, one of them is going to be brand new. Okay, so if we've got a metal bonded to a nonmetal, we know that that is ionic bonding. Okay, and in ionic bonding, we've got a transfer of electrons because one thing becomes a positive ion, one thing becomes a negative ion, one thing gained electrons, one thing lost electrons. There was a transfer of electrons. And when you get that positive and negative ion and they stick together, it's very strong. So ionic bonds are very, very strong bonds. If they're very strong, that means you have to put in energy to make these types of compounds separate. And so ionic compounds have very high melting points and high boiling points because you have to put in a lot of energy to separate these very strong bonds. Ionic compounds generally are solids that are very brittle. Now this little diagram here shows you why they are brittle. Let's say we have an ionic compound and it kind of has this alternating positive and negative ion structure where the positives and negatives are attracted to their opposites. And then if you hit an ionic compound maybe with a hammer, like say you have a big chunk of rock salt, NaCl, and you hit it with a hammer, well, that puts some stress. That causes the pluses and minuses, positive and negative ions, to move just a little bit. And if they move just a little bit, what we get is repulsion. Okay, this tiny box with tiny letters says repulsion. I wrote it bigger up here so you can see. But if we stress that just a little bit and make the positives next to the positives, negatives next to the negatives, they repel each other, and that's why ionic compounds tend to fracture if you put a little bit of quick stress on them, or maybe a little, not quite a little bit, but a decent amount of stress on them, then they will shatter apart. They won't bend, but they will shatter, and this is why they shatter, because you've moved the ions just enough where they can now repel each other where they were attracting each other. All right, now it's been a while since we've done Lewis dot diagrams, but we're going to take this example compound, magnesium bromide, and we're going to do a Lewis dot diagram of magnesium bromide. Here we go. Okay, magnesium. Magnesium, if you find it in your periodic table, you'll discover that magnesium has 2 valence electrons. Okay, so I'm going to draw those with 2 X's, one right there, one right there. Okay, there are my valence electrons on my magnesium. Bromine. Bromine is in group 17. That means it has 7 valence electrons. So let's draw 7 valence electrons around the bromine. 1, 2, 3, 4, 5, 6, 7. And this other bromine. 1, 2, 3, 4, 5, 6, 7. And we said there's going to be a transfer of electrons. Well, magnesium would love to get rid of 2 electrons. Each bromine would love to receive 1 electron. That's why they bond together in this ratio. And so what happens? Well, this electron is going to go right here. This electron is going to go right here. And that is going to leave us with 2 ions that are now going to stick together very strongly. And so this was kind of our rough draft, and now we're going to come up with our final Lewis dot diagram of an ionic compound. And this is not new. This is a review, folks. Okay, magnesium becomes an ion that has lost its 2 valence electrons, so it has nothing in its original shell. So we draw brackets because ions, remember, ionic compounds, see that I for ionic compounds, hiding in there are the brackets to remind you ionic compounds always have brackets, and that is a +2 charge on there. And then right next to it, we've got the bromine that in its original shell now has 1, 2, 3, 4, 5, 6, 7, 8 electrons. We draw brackets also because this became an ion. This became a negative ion by gaining 1 electron. And here's my final bromine with its 8 valence electrons, 1, 2, 3, 4, 5, 6, 7, 8, and my -1 charge. See, overall, we've got an overall neutral charge, and now I'm going to go answer